if you go up to 3 by 3 matrix, the determinant is given by a recursive calculation. Recursive means you're going to calculate 3 2 by 2 determinant. And to show you how to calculate, the best way is use an example. This is the A. To get this determinant of A, let me just put a determinant, change this into 2 lines. The formula simply tell you, you pick any row. In this case, I pick the first row because it have a 0 on this. Then pick the first element 2, take away this row and this column. Then you got a 2 by 2 determinant. Now pick up the second one with this negative 2. But you need to multiply another negative 1 of the 1 plus 2. Why? Because this position is the first row and second column. That's where the 1 times 2 come from. Do the same thing. Take away this row, this column, and what you have is that negative 1, 3, 1, 5. The third one, you take the 0 and take away the zeros. So negative 1, 5, 3, 4. 0 times anything is 0. You do need to consider that. So it's 2, 25 minus 4, because this times this. This is negative, negative make a positive. And then negative 1 times 5 is negative 5 minus 3. And then it's 2 times 21 plus negative 8, negative 16. So it's 42 minus 16, which equals 26. You're done. So that's how you calculate. Back to the formula. You don't have to pick the first row. You can pick the second one. Then what you're going to have? You're going to have A21, take this, A12, A13, A32, A33. You do 3 of them. The question is positive or negative? Well, then this one is going to be negative. Why? Because the second row, the first column, negative 1 to the 3, will be negative, positive, negative. That's the only thing you need to take care. So if you have a 4 by 4, then you need to make it like a 4 of the 3 by 3, so on and so forth, to do the calculation. But in reality, as long as you know how to calculate 2 by 2, 3 by 3, good enough. Use tools, MATLAB, the best, and Maple or anything. So how do we calculate the determinant with the parameter? You're going to see those questions later. I want you to find what count for R you put into the determinant, you can make it equal 0. So the result is a function for R. The particular R can make it equal 0. Most R will make it not equal 0. The calculation is the same because it's 2 by 2, A minus Ri, and equals this is A minus Ri. This is multiply the R, that's R, that's R. That's why you minus R on the major diagonal. So the determinant is this product minus 3 times 2 equals 6 equals R squared minus 7R plus 6. Now you know how to factor out that. That's R minus 1, R minus 6. And if you make it equal 0, either R equal 1 or R equal 6. So from the calculation we found, if the r equal 1 or r equals 6, the determinant equals 0. Otherwise, the determinant is not 0. So how to connect back to the old question I asked? Theorem is right here. The connection is, if the determinant is 0, the matrix is singular. If the determinant is not 0, the matrix is non-singular. That's the theorem. So instead of look at the matrix itself to be 0, we look at the determinant. If you talk about a number, this number A have reciprocal? The answer is yes or no, depends what is your A. If your A equals 0, the answer is no. If A not equal 0, the answer is yes. You can find then A times 1 over A equal 1. But when you deal with a determinant, when you deal with a matrix n by n, you cannot say, hey, look at the A. If the A not equal 0, so what? Do you have inverse? Not necessary. We already looked at many examples. They're not 0, but they don't have inverse. Look at the projections we had. You're not going to check this way. That cannot tell you anything. Instead, you look at the determinant of A. The determinant of A, if that not equal 0, yes, A inverse exists, non-singular. If the determinant equals 0, A inverse does not exist. What do you call? Singular. That's the connection. So when you deal with the matrix, you calculate the determinant first. If determinant is not 0, you go ahead, find the inverse. So how to find the inverse? Well, the easy way we showed you, just find the by definition. But that's not efficient. You don't want to solve this many equations. Again, if it's 2 by 2, I give you a shortcut. If it's 2 by 2, the first thing, determinant is AD minus BC. When this is not equal to 0, the inverse is going to be 1 out of the determinant. Now you figured out why it cannot be 0, because it's on the denominator. The old math, 0 cannot be on the denominator. To find the inverse, all you need is swap the D and the A position and switch the sign of the B and the C, negative B and the negative C. That's it. Then you get the inverse. Look at this example. So the determinant of A equals 6 minus 5 equal 1. Then the A inverse, look, 1 over 1, that's 1. Switch this 2, that's a 2, 3. And put the negative here and the negative here. You got it. That's the inverse. Then let's check. Multiply. If you multiply this to this, I'm going to show you it's 0. 3 times this, 3 times 2 is 6. 1 minus 5 is 5, you get a 1. 3, 1 times this, 3 times that's negative 3, plus 3, you get a 0. 5, it's going to be 10 minus 10, and that last one, 5, negative 5, and the plus 6. Now you got it, 1, 0, 0, 1. That's the inverse. Okay, that's easy. The next one, when you go to 3 by 3, it's not smart to do this way.